Hello, this is Mrs. Ward, and I'm going to go over the homework from the book from section 4.4, the chain rule, and that begins on page 290. So in 3 and 5, all they're trying to do is they want you to complete the table where you're identifying f of x and g of x. So just to remind you that f of x is the outer function, the g of x is the innermost function. So the g of x is what we said our u was. So this is the innermost function, which will be the x squared minus 3x plus 4, and then my outermost function is going to be the u, so that is going to be u to the 6th power. That's all they want you to do for these ones. So for number 5, your innermost function is x squared minus 1. Your outermost function is the square root of u, which we would probably write as u to the 1/2 power, because it would be easier to take a derivative that way. That's all you have to do for 3 and 5. All right. For the rest, for 7 through 34, you want to find the derivative. So when I look at 7, I have that 2x minus 7. So that's my innermost function. So my u is going to be 2x minus 7. I'm going to go ahead and find the derivative while I'm here. And the derivative is just 2. Then I'm going to rewrite y as u to the 3rd power. When I take the derivative, I'm going to have 3 times u to the 2nd power times the derivative of u, which I just said was that 2. I'm going to multiply that 3 times 2 and get 6. I'm going to replace the 2x minus 7 back in for the u, and I'm going to raise that to the 2nd power. And that's it. I'm done. I can't simplify. By no means do I want to FOIL that out. I'm just going to leave it like that. All right, so the next one is number 11. So I am going to write my u as the innermost function, which is going to be that 9 minus x squared. The derivative of u is going to be negative 2x. Then I'm going to rewrite f of x as u to the 2/3 power. Be careful about notation. Now I'm going to take the derivative, so I'm going to use the notation for the derivative. Take the derivative of something raised to the 2/3 power. I'm going to take 2/3 times u, subtract 1 from this power, so that would be negative 1/3. And then I'm going to multiply it by the derivative of u, which is that negative 2x. Now I'm going to rewrite it. This, since it has a negative exponent, is going to go down the denominator. So I'm going to multiply my numerator. So my numerator is going to be this 2 and this negative 2x, which will give me negative 4x. My denominator will be this 3 and then u to the 1/3 power. Oh, I should have substituted that back from when I was at it. So I'm going to substitute that back in for the u. So negative 4x over 3. And then u was 2x, 9 minus x squared. That's raised to the 1/3 power. Check and make sure nothing can simplify. By simplify, I have a 4 here and a 3 here, and nothing can simplify, so I'm going to leave it, and I am done. Number 15, before I even start this, I'm going to rewrite this as 9x squared plus 4. Remember, taking the root as a fractional exponent, so that's the 1/3 power. My innermost function is going to be that 9x squared plus 4. The derivative of that would be 2 times 9, which is 18. Reduce the power by 1, which is x. Remember, the derivative of a constant is 0. So I'm going to rewrite this y as u to the 1/3 power. Taking the derivative of something raised to the 1/3 power is going to be 1/3 u to the negative 2/3 power times the derivative of u, which is this 18x. So when I go to rewrite this, this u is going to go in the denominator. This 3 is also in the denominator. So I'm going to leave this 18x in the numerator, that 3 in the u, and that u again is the 9x squared plus 4 to the 2/3 power. Now when I look at this, 18 and 3 are both factors. They can simplify. So I'm going to have 6x over 9x squared plus 4 to the 2/3 power. Remember, it has to be a factor before you can simplify it. Okay, number 18, I am going to rewrite that as negative 3 times 2 minus 9x to the 1/4 power. So I'm going to write this up here. My u is going to be 2 minus 9x. The derivative of u is going to be negative 9. When I go to take the derivative, I'm going to first, I'm going to rewrite it first. I'm going to rewrite this as negative 3u to the 1/4. Okay, now, when you go to take the derivative of something raised to the 1/4 power, you're going to take this 1/4 times this negative 3, which will be negative 3/4. You subtract 1 from that 1/4, and that will be negative 3/4. And it's multiplied by the derivative of u, which I said was negative 9. Now, again, this 4 is in the denominator. This u is going to move in the denominator because it has this negative exponent. This 9 is in the numerator. So I am going to take this negative 3. I'm just going to write negative 3 times negative 9. You would probably do that while you were doing it, but I'm just showing every single possible step here. Here's the 4. Here's the u to the 3/4 power. Now I'm going to substitute back in my u and multiply. So this will be a positive 27. This will be 4. My u was 2 minus 9x. And this is raised to the 3/4 power. There is nothing that can simplify between that 27 and that 4, so I am done. Moving on to the next one. I could use the quotient rule, and if I use the quotient rule, then I wouldn't have to do the chain rule at all. But I want to rewrite it so I have to use the chain rule, because you might find it easier to use the chain rule, especially if I have a constant in my numerator. I think it's easier to use the chain rule. So I'm going to rewrite y as this 1 times this quantity of x minus 2, and since it came from the denominator, and it's understood to be the first power, I'm going to raise this to the negative 1 power. Now, if I think of this, the u could be x minus 2. The derivative of u is just 1. So when I take the derivative, I'm going to rewrite this as u to the negative 1. Taking the derivative of something raised to the negative 1 power is going to be negative 1 times u. Reduce this power by 1, so that becomes negative 2. And then multiply it by the derivative of u, which is just 1. So my numerator is just going to be this negative 1 over my u, which is x minus 2 squared. And that's it during the chain rule. I could, by all means, keep the denominator the same, take the derivative of the numerator, which would be 0, minus, leave the numerator alone, take the derivative of the denominator, which is just 1, all over my denominator squared. When I do that, this is multiplied by 0, so that's gone, so I have negative 1 over x minus 2 squared. Either way is fine. But if I have a constant in the numerator, I prefer to do the chain rule. Number 23, I'm going to rewrite this as 1, and this is the x plus 2 to the 1/2 power. I'm going to choose to use the chain rule. So I'm going to have 1 times x plus 2 to the negative 1/2 power. So over here, I'm going to say u is equal to x plus 2. The derivative of u is just 1. Rewrite this as u to the negative 1/2 power. Taking the derivative of something raised to the negative 1/2 power is negative 1/2 times u. Reduce this power by 1, so that would be negative 3/2. And then multiply the derivative by u, which is just that 1. So I'm going to have negative 1 over 2. That u was x plus 2 to the 3/2 power. Again, you could have done the quotient rule. You're going to get the exact same thing at the end. Number 25. Now I have x squared times x minus 2 to the 4th. So I'm going to have to do the product rule. And when I take the derivative of this one here, I'm going to have to use the chain rule. So let's just start really slow. So if I take the derivative, I'm going to take the derivative of that x squared first and make this 2x. Leave that x minus 2 to the 4th alone. Then I'm going to have plus, and then I'm going to do x squared. And now I'm going to take the derivative of this I'm going to take the derivative of this. So over here, I'm going to take the derivative. So I have x minus 2 to the 4th. So I'm going to say my u is equal to x minus 2. My derivative of u is just 1. So this I'm going to think of as u to the 4th. So I'm going to do 4 times u to the 3rd times the derivative of u, which is 1. So this will be 4 times the x minus 2 to the 3rd. That is the derivative. So this I'm going to put over here. So I'm going to have 4 times x minus 2 to the 3rd. So this is the derivative of this, and there's all the work that shows that. Now, I'm going to clean up a little bit before I start factoring out. So here, this is 2x. This is x minus 2 to the 4th, plus, put the 4 in front, this is 4x squared times x minus 2 to the 3rd. Now I have to factor completely, so I look at the 2x and the 4x squared. The greatest common factor between those two is 2x. I'm going to factor that out. Then I have x minus 2 to the 4th, and I have x minus 2 to the 3rd. The lowest power is the 3rd, so I'm going to write x minus 2 to the 3rd. I like to do the bracket because that's telling me that I'm factoring something out. If you don't like the bracket, then don't do the bracket. All right, I've already factored out from this first term here. This is the first term that I'm looking at. That first term here, I've already factored out the 2x, so that's already taken care of. But I have this x minus 2. This I only factored out to the 3rd. This one's raised to the 4th, so I still need one more. So I'm going to write x minus 2. Now, I don't really need those parentheses, but I'm just going to leave them there for a second. Then I'm going to write this plus sign. Here's that plus sign. My second term is this 4x squared, which I only factored out a 2x, so I have to have a 2x left. And then the x minus 2 to the 3rd, I already factored out to the 3rd, so I'm done. That's all I have left. So when I clean this up ever so slightly, I'm going to have 2x times x minus 2 to the 3rd. I really don't need these parentheses, so I'm going to get rid of them. I add x plus 2x, and I have 3x minus 2. And that has to go in parentheses, that has to go, this has to go in parentheses, this has to go in parentheses because it's being raised to the 3rd power, and then that is just fine. Okay, remember, you have to do the product rule and the chain rule. Okay, the next one, I am going to do the same thing, but now I'm going to do the quotient rule and the chain rule within the quotient rule. So I'm going to rewrite this as x squared plus 1 to the 1/2 power. When I go to take the derivative, I'm leaving the denominator the same, taking the derivative of the numerator, so the derivative of x is just x, minus, leave the x alone, and now I have to take the derivative of the x squared. I have to take the derivative of this x squared plus 1. So over here, I'm going to go do that. So my u is equal to x squared plus 1. So the derivative of u is going to be 2x. Then that is u raised to the 1/2 power. Taking the derivative of something raised to the 1/2 power. I guess I should So then to take the derivative of that, it's going to be 1/2 u to the negative 1/2 power. And then I'm going to multiply it by the derivative of u, which is 2x. And then the 1/2 times 2 will just be 1. So this will end up being x over x squared plus 1 to the 1/2 power. So I'm going to put that in here. X, oh no, I'm going to leave it as negative 1/2. I am, now I'm making my life easier. I'm making this x times x squared plus 1 to the negative 1/2 power. Forget I ever put that in the denominator. I'm going to want to leave that in the numerator. So x times x squared plus 1 to the negative 1/2. because I'm going to have to factor that out. So I have that. I'm going to clean this up a little bit. So I'm going to have x squared plus 1 to the 1/2 power. I don't need that 1. Minus, and then x times x is x squared. And then x squared plus 1 to the negative 1/2 power. So that x squared plus 1 appears here. It appears here. Once the 1/2 power, once the negative 1/2 power, the lowest power is that negative 1/2. So I'm going to factor out x squared plus 1 to the negative 1/2 power. Here's my brackets to show you that I put stuff in there. This one, when I factored it out, I factored out a negative 1/2 power, but I have a positive 1/2 power. So I asked myself, why do I have to add the negative 1/2 to get a positive 1/2? Or I can take this positive 1/2 and minus the negative 1/2. Either way, I'm going to get x squared plus 1. Here's this minus sign, here's that minus sign. And then x squared is there. And then I've already factored this one out, so I don't need to write it again. So now when I go to write this, I'm going to have the quantity of x squared plus 1 to the negative 1/2 power, which means it needs to be moved to the denominator. These two will equal 0, and then I'm going to be, so this will be just times 1. So 1 is going to be my numerator, and then this x squared plus 1 to the 1/2 power will be my denominator, and that's the derivative. Again, this one, I did the product rule, and then I had to do the chain rule within the product rule, but I was only doing the chain rule for that denominator. This is another example where I have to do the product rule and the chain rule, but the squared is the outermost function, so I'm going to use a chain rule for the entire thing. So when I go to do this, I'm going to rewrite, I'm going to say my u is that fraction, which is x plus 5 over x squared plus 2. That's my u. To take my derivative of this, I have to do the quotient rule. To do x squared plus 2, the derivative of the numerator is 1. Minus, I leave my numerator alone, take the derivative of my denominator, which will just be 2x. All over my denominator squared. So when I clean this up, I'm going to get x squared plus 2. Now I'm going to distribute this 2x and this negative sign at the same time. So we have minus 2x squared minus 10x. All over this x squared plus 2 squared. When I combine my like terms, I'm going to have negative x squared minus 10x plus 2 all over x squared plus 2 squared. So going back here, I'm going to rewrite g of x as that u raised to the second power. Taking the derivative of something raised to the second power is going to be 2u raised to the first power times the derivative of u. So I'm going to do, see, that 2 is in the numerator. That u is that x plus 5. It's really messy handwriting. This is good. X squared plus 2. That's the first power, so I don't have to write anything. Times the derivative of u, which is this thing here. So times negative x squared minus 10x plus 2 all over x squared plus 2 squared. Now, I can rewrite this as 2 times x plus 5 over x squared plus 2 times x squared minus 10x plus 2 over x squared plus 2 squared. The numerator, I'm just going to leave those as all separate parentheses. So 2 times x plus 5 times negative x squared minus 10x plus 2. And then my denominator, this is understood to be the first. So when I combine those, I'm going to add my exponents when I multiply it, and they'll be raised to the third power. So that is number 31. Number 43, evaluate the derivative of the function at an indicated point and then use a graphing utility to verify your results. So I am going to say that my u, I'm doing it the exact same way that I did before, except for at the end, I'm going to substitute in that 2 to find my derivative at that point. So u is going to be that t squared plus 2t plus 8. The derivative of u is going to be 2t plus 2. Here I'm going to rewrite this s of t as that t squared plus 2. Oh, no, I don't. I rewrote the u. So this is going to be u to the 1/2 power. Now I take the derivative of something raised to the 1/2 power. So that's going to be 1/2 u to the negative 1/2 power times the derivative of u, which is this 2t plus 2. Can I factor out a 2 while I'm here? I will. So 2 times t plus 1. The reason why I did that is because now the 1/2 and the 2 can simplify because now that 2 is a factor. So I'm going to put the t plus 1 in the numerator. The t squared plus 2t plus 8 in the denominator. Now I'll make it a positive exponent. So that's t. That's my derivative. Now I want to find the derivative at 2, 4. So remember, I just want to substitute in the x value, or the t value in this case, which is 2. So I'm going to have 2 plus 1 over 2 squared plus 2 times 2 plus 8. I'm going to take the square root of that. So the numerator is going to be 3. The denominator will be 4 plus 4, which is 8. 16, the square root of 16 is 4. Again, you can probably do that on your calculator. And I get 3/4. So that is my answer. To check it on my calculator, I am going to take this and put it in my calculator. So let me just write it down. Okay, so I pick up my calculator. Let's add a new page. That's a calculating page. You hit menu, calculus, and then you're going to find the numerical derivative at a point. You can only find the numerical derivative. You can only find the derivative at a point. You cannot find it at anything else. So the variable, I'm just going to put x in instead of t, so I'm going to leave it as x. I am going to go down here and I want to find the derivative at 2. And then I want the first derivative, and I'm going to hit OK. It gives me this. It says d of x. That stands for derivative. I am going to put in the formula, which was, again, it was t. I'm switching it to x squared. And then I'm going to have plus 2x plus 8. And I want to find the derivative at 2. Double check that says 2. And we get 3/4. So that's a quick way to check and make sure you got your answer correct. All right, moving on to the next one. In exercises 49, find the equation of the tangent line to the graph at the indicated point. Use a graphing utility to graph the function in its tangent line at the point, and use the derivative feature of your graphing utility to confirm your result. Let's go. So my u is going to be 3x squared minus 2. So I'm going to think of f of x as u to the 1/2 power. The derivative of u is going to be 6x. The derivative of something raised to the 1/2 power is going to be 1/2 u to the negative 1/2 times the derivative of u, which I said was 6x. The 1/2 and the 6 will simplify to 3x. So I'm going to have 3x in my numerator. And 3x squared minus 2 raised to the 1/2 in my denominator. And now I want to find the derivative at 3. So I'm going to substitute in 3. Oh, I hope I have the mental math skills to do this. So 3 times 3 is 9. This will be 27 minus 2, which is 25. The square root of 25 is 5. So I get 9/5. Remember, that's my slope. And the point they give me is 3, 5. So the point they give me is 3, 5. I'm going to do point slope. So I'm going to have 1 minus 5 is equal to 9/5 x minus 27/5. I'm going to add 5 to both sides. If I add 5, that's going to be minus 2/5. Okay, so that is what I got. I am going to add y is equal to 9/5 x minus 2/5. Before, I'm going to sort of go in that reverse order. I'm going to actually use the derivative of my calculator to confirm my results first before I graph it, because there's no sense graphing it if I'm wrong. So I'm going to do menu, calculus, derivative at a point. This time we're doing the points. I don't even remember. Write that down. 3. So we're doing the derivative at 3. And then first derivative, okay. It's going to be the square root of 3x squared. Oopsie. 3x squared minus 2 at 3, and I get 9/5. That's what I got. Now I'm going to add another page. I'm going to do a graphing page. I'm going to graph the original function, which is 3x squared minus 2. That's the original function. And now I'm going to graph the tangent line, which is 9/5 x minus 2/5. Oopsie. I'll drive. Pause, please. So that's my graph. Really hard to see that it's tangent there, but it is really hard to see. Okay, moving on. Okay, 51, find the second derivative. So I'm going to start just like I did before. U is going to be x squared minus 1. The derivative of u is going to be 2x. So to find the first derivative, I have 2u to the third. To find the derivative, oh no, that's me just rewriting. To find the derivative, that's going to be 3 times 2, so 6u. Reduce that power by 1, so that's squared, multiplied by the derivative, which is 2x. So when I rewrite this, the first derivative is going to be 12x times u, which is x squared minus 1 squared. Now that's my first derivative. Now I need to find my second derivative. So I'm going to have to do that whole chain rule thing again. And since I have this x here, I'm going to have to do the product rule as well. So if I go to find a second derivative, let's say I take the derivative of 12x first, which will just be 12. Leave that x squared minus 1 squared alone. Then I do plus. Now I'm leaving that 12x alone. And now I have to find the derivative of this. So that is going to be, let's call this g of x. And that's going to be x squared minus 1 squared. So my function is u squared. Over here I'm going to say u is equal to x squared. Oh, I can just do that. U is equal to x squared minus 1. My derivative is 2u. So when I take the derivative of this, that's going to be 2x. And then I am going to, 2u. This is 2u raised to the first power and multiplied by the derivative, which is 2x. So then this derivative ends up being 4x times u, which was that x squared minus 1. So this is 4x times x squared minus 1. So I'm just going to rewrite it for a second before I start factoring out. So this 12 will stay that, x squared minus 1. I'm not going to change anything there. I am going to take this 12x times this 4x and make it 48x squared. And then this is x squared minus 1. Since I have x squared minus 1 in both terms, I have it here and here. This one's to the second power. I didn't write that. I'm going to be able to factor out one of those. I can factor out x squared minus 1. Between the 12 and the 48, I can factor out a 12. Then I do brackets. I do like the brackets better. I've already factored out this 12. This x squared minus 1, I factored out 1, so now I have another one left. And then from this 48x, I need a 4 and an x, and I've already factored out that x squared minus 1. I do not need these parentheses, so I'm going to erase them because I didn't have to distribute anything. And then this derivative is going to be 12 and then x squared minus 1, and then this will be x squared plus 4x minus 1 if I put it in descending order, and that is the second derivative. And then the last one, it says, let's think about it. So we're trying to find f of g of x and g of f of x, and where f and g are shown. So they give me the graphs of the function, and they want me to find the derivative. So for a, they want me to find the derivative at f of g of x. So if I go back and I look at what the derivative is in my book, remember, you're doing the derivative of f of g of x. So my innermost function, it's f of g of x times the derivative of g of x. So when I look here, this one is going to be for 1. So remember, g of 1, just g of 1, is I go to 1, I look here, and I see that that g of 1 is 4. So I'm going to find the derivative of f at 4 times the derivative of g at 1. So then I go here, this is f, this is f. I want the derivative at 4, so I want the slope of this line. So it looks like I'm going from 0 to 5. That's my rise, and then my run is from 2 to 6. So that slope is 5, 6. And then if I look at g of 1, so I go over here, g of 1, and I want the slope at this point, which is 0. I didn't have to do all that other work. And then this will end up being 0. So going the other way, I'm going to do g of f of x times the derivative of f of x. So this one we're doing, because that's the formula for s, and we're doing 4. So I'm going to do the slope of f of 4 times the slope at f of 4. So f of 4, I'm going to erase all my markings. 4. So f of 4 is here, which looks like it's about 2. And my slope at 2 I'll pull, please. So f of 4 is a little bit above 2, so I'm going to be, when I go to find the slope, I'm going to put like 2.1, and that's f of 4. So at 2.1 or 2 point whatever, I'm finding the slope of this line here. So my rise from 4 to 6 is 2. My run from 2 to 6 is 4. So that slope is 1/2. So that slope is going to be 1/2. And then plus the slope at 4. So here's my slope at 4. So my slope at 4, we said, was, my rise was 5, and my run was 4. Oh, did I put 4? 5/4. Bad math last time, didn't matter, multiply by 0. 5/4, and I end up with 5/8, and that's going to be my answer. I hope this helps, and I will see you next time.